In this tutorial, a simulation is carried out to determine the transport properties by means of the Green-Kubo formalism. These kind of simulations are carried out in the canonic ensemble. Select the SI system of units. Enter the reference length, reference energy, and reference mass unit. We are going to perform a molecular dynamics simulation in the canonic ensemble to calculate the transport properties. We have to choose an integrator. Here we use Gear's predictor corrector. Enter the time step here. Enter the number of Monte Carlo relaxation loops for pre-equilibration. Enter the number of equilibration molecular dynamics time steps in the canonic ensemble. Enter the number of production time steps where the transport properties are actually sampled. Note that the number of time steps is typically rather large, on the order of 1,000,000 or a few million time steps. Specify the frequency by which the running averages and the actual averages are updated. This specifies the frequency by which the result file is updated. In order to calculate the transport properties, turn on this tab to enable the calculation of transport properties. Enter the temperature, the density, and the number of particles. Note that the number of particles should be relatively large, something like 2 to 4,000. This specifies the frequency in terms of time steps for sampling the Green-Kubo equations. This defines the length of the sampled correlation functions, given in terms of time steps. This specifies the time interval separating subsequent autocorrelation functions. You have to make sure that this time is greater than the time by which the correlation functions decay to values below 1 by e. This graphics visualizes how the correlation functions are sampled by ms2. This specifies the frequency by which the RTR file is updated, that is, the output file for the autocorrelation functions. For a value of 1, ms2 writes every correlation function into the RTR file, whereas for a value of 2, every second one is written. At the molecular force field model, here we are using a potential model for methanol. The chemical potential is not determined here, so specify none. Here, the cutoff radius has to be specified. The dielectric constant for the reaction field medium has to be entered here. Save the parameter file here. Run this simulation with ms2 that is compiled such that the transport properties are sampled. This is one of the compile options. Thank you for watching this tutorial.